Okay, students, part 2. I try to break the videos up to give you a break. Okay, so next set, we stopped at number 34 on the last page. So number 36, I have 3t minus 27. It says complete each factorization. So if I have 3t minus 27, you're thinking about the factor tree. Okay, you're thinking about 3t, you're thinking about 27, you're thinking, what do they have in common? So in the book, they gave you the 3. They gave you the parentheses, and they gave you t. So I'm trying to figure out, what are you missing? So I want you to think about your 3 tables. Here, I have a 3 on the outside. I'm trying to make 27. So 3 times what will give me 27? 9, and that's your answer. That's it. You're just thinking about your timetables. You're just kind of going backwards. The same thing for 38, 5b minus 15. They gave me b minus 3, and it's also in your text. So if I'm thinking about what is the greatest common factor, what do they both have in common? Think about it this way. If you broke down 5b, just like we did before, 1 times 5 is 5. For 15, 5 times 3 is 15. What do they both have in common? You're right, a 5. So that is what you will bring out in the front. They have a 5 in common. This 3 and 27, you could broke that down. 1 times 3 is 3. 3 times 9 is 27. Broke that 3 down a little bit more. 3 times 3. You would have found that they have a 3 in common. Okay. So far, so good. You were doing well. I have 6x minus 15. In the book, they gave me 2x minus 5 in parentheses. They want me to fill in the blank. What should go here? Thinking about your timetables. What times 2 will give you a 6? 3. So really easy. They're just trying to make sure you got your timetables down packed. 3 times 2 gives you 6x. 3 times 5 will give me negative 15. Okay. You're doing very well. All right, next I have number 42. Let me scoot this over to make sure you can see it well. Okay. I have 3b minus 9b minus 6ab. So in the book, it gave me 3b on the outside, and I need to fill in these 2 blanks. I need to fill them in. So if I have 3b on the outside, okay, how can I get 3b to the second power? What am I missing? I have 3b, but I need 3b to the second power. You're missing b. Very good. Okay, so it's just kind of like distributive property. You're multiplying to tell me what are you missing. That's it. 3b times b is 3b to the second power. Next, negative 9b. If I have 3b so far, 3 times what would give me 9? Okay. And you don't need the b because you have one already. You have one on the outside. So I need 9b. You have 3b so far. So the only thing you're missing is 3. So b minus 3. And they gave me minus 2a. Okay. The same thing for 44. I'm underlining the blank spaces that I saw in my textbook. So 10x to the third power plus 8xy minus 4xy squared equals 2x. So they're asking you to think about your timetables. 2x times what would give you 10? So think about your timetables. 2 times what would give you 10? 5. If you have an x on the outside, but you need a total of how many? 3. So how many do you need inside? I need 2 more to make it, you need to make it complete. Okay, you add exponents and you multiply your numbers. Okay, so I have 2x here. Of course, this will be 8xy, which they have here already, minus 4xy to the second power. So they needed the last part. So here I have 2x. So they're asking me 2 times what to give me 4. Your answer should be 2. Okay. I need 1x. I have 1x. I already sitting on the outside. I need y to the second power. I have no y's at all. So you need both of those y's to go inside. Okay. You're doing well. 46. A to the third power minus a to the second power. Okay, and the answer in the book gave me a minus 1. So I'm missing something that should go right here in front. What should go right here in front? Okay, I have 1a here, but I need how many? 3 of them. So how many you need on the outside? I need 2 to make this complete. Because a to the second power, this of course is a to the first power. So this will make a to the third power. And then a to the second power times 1 is the same thing. A to the second power. Anything you multiply by 1 is called identity, will give you the same if you did distributive property. Okay, that's 46. Okay, 48, the factoring part. Factor each polynomial. I think y'all got this down pat. Okay, so I need you to tell me, doing a factor tree, what they have in common. This is 1 times 2. This is 2 times 5, all right? This only has the letter y, my variable y, but this doesn't have anything. So what would you say they have in common? The only thing I see that they have in common is a 2. So I want you to bring that 2 out, and then give me a parentheses. So your timetables, bring that timetable out in the front. Tell me what they both have in common. Now help me complete this. So I got a 2 on the outside, but I need to make 2y minus 10. So I need y minus, and how can I get 10? 2 times what will give me 10? 5. And that's your answer. So this is just really about your timetables. That's it. If you did this is like backwards distributive property. If you multiply this out for me, you would say, Miss Thomas, this is 2y minus 10, which is absolutely correct. Okay. 4t plus 12. You're thinking about what they have in common. What they have in common. Okay. 2 times 2. You break that down slowly. All right. So they both still have a 4 in common. So you always write what they have in common and then bring it out into a parentheses. Now, help me complete it. I need 4t. I have 4. I'm missing the t. I need 12. I have 4 so far. So I'm thinking of my timetables. 4 times what would give me 12? 3. You're going to do the same thing for 52. You're going to find your greatest common factor. So I want you to do the factor tree here. Think about 2 numbers that you can multiply to get 15. 2 numbers that you can multiply to get 3. So we're just doing our timetable. Then you're telling me what you have in common. Look at the A's. I have 2 here and I have 1 over here. So if you had to circle it, I see 5. No. All right. Thank you so much. I see 3. Yes. I just want to make sure you can notice when you made a mistake. And I see 1A and I see 1A. So factor out a 3A for me. All right. And help me complete it. I need 15A to the second power. I have 3A so far. So I need 5 and 1 more A to make that 15A to the second power. Okay, I have 3A already. The only thing you can add here is a 1 to make that complete. I want you to think of distributive property. Start trying to multiply that out. And I want you to get to a point where when you look, you'll say, I know what the greatest common factor is, Miss Thomas. Okay, but until then, use your factor tree. Use your factor tree to help you find the answers. Your greatest common factor. Use your factor tree. Okay, tell me what you see that they have in common here. Okay, I see 2 here, 2 here, 2 over here, 2 underneath the 12. I see they have a 4 in common. How many Y's do they both have in common? I have 3 over here. I have 2 over here. So I had to circle and underline. How many would you say they have in common? You're right, they have 2 in common. So I have 4y to the second power, but I need you to help me make 8. So think of your timetables. 4 times what would give me 8? 2. I need 3 Y's. I have 2 of them so far, so I need 1 more to make that complete. Bring down your minus sign. I'm thinking of my timetables. I have 4, but I need 12. 4 times what would give me 12? 3. Do I have enough Y's? Yes, you do. Because here, you need 2. I have 2. This is your answer. Here, I'm thinking about my greatest common factor. All right, I'm writing down, all I see is 3 B's over here. I see 1 times 3, and I see 2 B's over here. I just want you to break that down slowly and tell me what they have in common. I only see a 1 that they have in common. And I see how many B's? 2 of them. So bring that B squared out. All right, next you have, I need 1 B to make it complete because I need 3. I only have 2, so I need 1 more. I need the entire 3 here, and B to the second power, do I have it? Yes, I do. So do distributive property and make sure it makes sense.